Welcome back, everyone, to another special chapter in our journey. A journey where we uncover the things you were never told about gemstones, minerals, and the forgotten forces that shaped our world long before humans understood their power. Today's episode is different because among these 10 stones, each one capable of restoring soil, purifying water, or absorbing toxins, there is one stone ranked at number one that changed everything I thought I knew about environmental minerals. It isn't rare, it isn't beautiful, and yet it may be the most important stone humanity will ever depend on. Some scientists quietly call it the Black Guardian. Others warn that ignoring its value today could become one of the biggest mistakes in environmental investment by 2026. So whatever you do, don't skip this video, especially if you're someone who cares about the future, sustainability, or the hidden stories buried beneath your feet. Missing this could mean misunderstanding one of the most crucial materials shaping our world. Before we begin, let's set the tone for the next 10 minutes. Imagine stones formed not for beauty, but for protection. Stones born from volcanoes, ancient seas, vanished forests, and deep mantle fractures, each carrying a silent mission to clean the earth we've damaged. Some of them healed rivers, some purified ancient drinking wells, some absorbed poisons no human technology could remove. And one, the stone ranked at number one, may already be in your home, sitting quietly, unnoticed, yet capable of doing more for the planet than any gemstone ever discovered. If you feel, even slightly, that this may be the beginning of something new, a new way of understanding stones and the world they protect, then leave a comment saying, "I like this video." It helps me know you're still here, walking beside me on this strange and beautiful path of discovery. Stay with me until the end, because the stone at the top of this list might surprise you. It might challenge everything you thought you knew about value, rarity, and environmental healing. And who knows, you may already own it without realizing its importance. And of course, if you haven't subscribed yet, consider doing so. Not for the algorithm, but so you don't miss the next journey into the hidden histories shaping our world. If you're busy right now or watching this at a moment when you need quiet rather than information, then save this video for later. Because what we're about to explore is a journey unlike any other. A journey into 10 stones you've never seen this way before, and one stone whose power you should never overlook. Number 10, Bauxite. The ordinary stone that might save the earth. The first time I held a piece of bauxite in my hands, deep inside an abandoned mining trench on the red plateaus of Guinea, I remember feeling a strange mixture of disappointment and curiosity. At first glance, it didn't look like a gemstone. It didn't shimmer, glow, or reveal any hidden fire. Instead, it sat heavy and silent in my palm. Rough, rust-colored, almost forgettable. But then the sun shifted. Light caught the pale streaks of alumina inside the stone, and suddenly it wasn't ordinary anymore. It was a mineral carrying the future of our planet. And if that unexpected shift already hooked your attention in these opening seconds, feel free to leave a comment. It tells me you're still walking with me through this strange and important discovery. To understand why bauxite appears here as the 10th stone you shouldn't overlook in a world facing environmental crisis, we must travel across three major regions shaped by millions of years of geological transformation. Australia, with its vast open-pit bauxite fields stretching across Queensland and Western Australia. Guinea, whose red highlands hold some of the planet's highest-grade ore. And India, particularly the Eastern Ghats, where seasonal rains carved ancient rocks into rich bauxite deposits long before the first human settlements emerged. Archaeological studies show that early communities often built homes, farms, and storage pits near these mineral-rich areas, drawn unknowingly to the fertile land created by natural bauxite weathering. Though they didn't understand the mineral's future importance, their settlement patterns reveal a quiet connection between early human survival and this unassuming stone. Bauxite extraction today involves surface mining, a method far less destructive than deep tunneling. Workers remove only the top layer of soil, gather the ore beneath, and then replace the earth in a cycle known as mine and restore. In many regions, forests, grasses, Even wildlife return within a few seasons. This regenerative process is why modern environmental scientists view bauxite as a sustainable mineral. Its extraction can be temporary, reversible, and ecologically responsible when properly managed. But the true environmental miracle lies in what bauxite becomes. When refined into alumina and processed into aluminum, the resulting metal can be recycled endlessly. Each cycle uses only a fraction of the energy needed to create aluminum from raw ore. Estimates show that recycling aluminum saves up to 95% of energy, reducing emissions, reducing mining, and reducing the wounds we carve into the earth. So while bauxite may not shine on a jeweler's display, it may shine far brighter in humanity's future. If that realization surprised you, or if you didn't expect the least glamorous stone to carry the greatest environmental impact, feel free to leave your thoughts in the comments. I'd love to know what part of its story struck you most. And before we move forward, here's a question to spark discussion. Do you think environmentally protective stones like bauxite could one day become more culturally valuable than diamonds? Share your perspective and consider posting this video in gemstone or sustainability groups on Facebook or Reddit. You never know who might be inspired by a stone that quietly protects the planet. Number 9. Diatomite, Kieselguhr. The fossil stone that cleans the world. The first time I uncovered a chunk of diatomite along the eroded banks of Lake Shala in Ethiopia, I was struck by how light it felt. Not just physically light, almost weightless, but spiritually light as well, as if I were holding a piece of the sky instead of a stone. Its surface was chalky, soft, and pale, like crushed moonlight. And if that delicate image already caught your curiosity in these opening seconds, feel free to leave a comment. It tells me you're still here with me, stepping deeper into a story that stretches back millions of years. To understand why diatomite earns its place as stone number 9, we must travel to the places where ancient waters once ruled the earth. You'll find it in Ethiopia, among extinct volcanic lakes, in California, within the dusty beds of prehistoric seas, and across China, where ancient river systems laid down layer after layer of microscopic life. Diatomite is not an ordinary mineral. It is the fossilized remains of diatoms, tiny algae that lived long before humans existed. Each piece is a graveyard of ancient life, compacted into a porous, feather-light stone, capable of absorbing nearly anything it touches. Its origin reveals its environmental power. Over millions of years, diatoms built shells from silica, shells so intricate and delicate that they resemble miniature pieces of architecture. When these organisms died, their shells settled into thick beds, creating diatomite deposits that look like compressed clouds. Archaeologists studying early civilizations found traces of this mineral near water filtration pits, hinting that ancient communities unknowingly relied on its natural purifying abilities long before modern science understood them. Today, diatomite is mined using open-pit extraction. The process is surprisingly gentle. Workers remove thin layers of soft sediment with minimal disruption, often restoring the land soon after. Because the stone is so light and abundant near the surface, deep excavation is rarely necessary, making it one of the least invasive forms of mining in the mineral world. Its environmental impact is where diatomite truly shines. Because of its microscopic porosity, it can filter bacteria and impurities from drinking water, remove toxins from rivers and lakes, absorb harmful chemicals from soil, and even trap pollutants in industrial air systems. This is why diatomite is sometimes called the fossil sponge of the earth. It silently cleans what humans contaminate. Its appearance varies from powdery white to soft beige, often carved into filtration blocks or ground into a fine, silky powder. Unlike gemstones used for beauty or jewelry, diatomite's value lies in its quiet function, its ability to clean, purify, and protect. If the idea that a stone made from ancient microscopic life could help save modern ecosystems surprised you, feel free to leave your reaction in the comments. I'd love to know what part of its story resonated most. And before we continue, here's a question to spark discussion. Do you think stones that purify the earth, like diatomite, could become more valued in 2026 than traditional gemstones like diamonds? Share your thoughts. And consider posting this video in environmental or gemstone groups on Facebook or Reddit. You never know who might be inspired by a stone built from the memories of ancient oceans. Number 8. Olivine, the green crystal that eats CO2. The first time I found olivine scattered across a volcanic shoreline in Iceland, I remember the moment vividly. The beach looked like someone had spilled thousands of tiny green gemstones across black basalt sand, glittering, shimmering, and pulsing with an inner brightness that felt almost unnatural. And if that image already pulls you in during these opening seconds, feel free to leave a comment. It tells me you're still here, journeying deeper with me into a story where geology and climate science collide in unexpected ways. To understand why olivine appears on this list, we must follow the Earth's most ancient forces. This mineral, one of the first to crystallize from molten rock, appears across Hawaii, Iceland, Oman, Papua New Guinea, and even the depths of the African Rift Valley. Wherever volcanoes once breathed fire, olivine crystallized beneath the surface, forming bright green grains that eventually rise to the light through erosion. Archaeologists studying early Polynesian cultures found traces of olivine in ceremonial offerings, carved into beads or sprinkled on sacred ground. They didn't know its chemical potential, but they sensed its symbolic power, a stone born from fire yet strangely cooling to the touch. Today, what makes olivine astonishing is not its beauty, but its chemistry. When exposed to moisture and air, it chemically reacts with carbon dioxide, trapping it inside new minerals. In simple terms, olivine eats CO2. Just 1 ton of weathered olivine can capture up to 1 ton of atmospheric carbon dioxide. That discovery has sparked global interest, with scientists exploring olivine beaches and engineered rock fields as potential natural carbon removal systems. Mining olivine is surprisingly gentle compared to industrial minerals. It forms in shallow ultramafic rock layers, allowing extraction from surface deposits using limited machinery. Because it's widely available and requires minimal processing, the environmental footprint of olivine mining can be extremely low, especially when paired with land restoration. Its appearance is unmistakable. Olive green crystals, olivine is typically found as small pebbles, irregular crystals, or sand-like grains that sparkle under direct sunlight. These forms are too fragile for high-end jewelry, but perfect for spreading across beaches or soil where they can naturally absorb CO2. If the idea that a volcanic crystal could help slow global warming surprised you, or if you never expected a simple greenstone to play a role in Earth's future, feel free to share your reaction in the comments. I'd love to know what part of this story connected with you most. And before we move to the next environmental stone, here's a question for you. Do you think stones that can literally remove carbon from the atmosphere, like olivine, could become more culturally valuable than diamonds by 2026? Share your thoughts, and consider posting this video in climate science or gemstone groups on Facebook or Reddit. You never know who might be inspired by a stone forged in fire that fights for the future. Number 7. Serpentine, the ancient green stone that heals the Earth's soil. The first time I uncovered serpentine beneath a collapsed hillside shrine in northern Greece, I remember being struck by its texture before its color. Smooth, almost waxy, with patterns that curled and twisted like the skin of an ancient serpent. And when sunlight slipped across its green surface, the stone seemed to shift, alive, breathing, almost watchful. And if that strange, living quality already pulled you in during these opening seconds, feel free to leave a comment. It tells me you're still here, stepping deeper into this forgotten chapter of Earth's restoration stones. Serpentine forms in places where tectonic plates collide, grind, and reshape each other. You can find it across Greece, Italy, New Zealand, the Himalayan arc, and parts of California, where ancient seafloors were thrust upward into the light. Archaeologists studying early settlements in these regions discovered serpentine talismans carved into animal shapes or worn smooth as pocket stones. But the most fascinating findings come from agricultural sites. Serpentine fragments intentionally mixed into soil layers thousands of years ago. Ancient communities didn't know the chemistry, but they knew the effect. Crops grew better, soil felt softer, plants seemed healthier. Modern science explains why. Serpentine contains magnesium-rich minerals capable of binding and neutralizing heavy metals, preventing them from poisoning soil and water. In contaminated land, whether from natural mineralization or human activity, serpentine acts like a filter, locking harmful elements away inside stable crystals. This property has made it a key component in phytoremediation projects, where plants and stones work together to heal toxic landscapes. Extraction of serpentine is relatively gentle. Because it forms near the surface in altered ultramafic rock, miners often collect it through shallow quarrying, removing only thin layers of weathered stone without deep drilling or explosives. And unlike many minerals, serpentine deposits are often paired with natural vegetation that quickly regrows after extraction, making environmental restoration faster and easier. Visually, serpentine is one of the Earth's most expressive stones. Soft apple green, deep forest tones, marbled yellow-green veins, sometimes streaks of white, black, or golden fibers. Shapes vary from massive blocks to rounded river stones and carved amulets. Its softness allowed ancient artisans to sculpt it into ritual objects, many of which archaeologists now find buried alongside seeds, tools, and offerings, proof of its connection to agriculture and renewal. If the idea that ancient farmers used serpentine to heal their soil long before environmental science existed surprised you, feel free to share your reaction in the comments. I'd love to know what part of its story resonated with you the most. And before we move forward, here's a question to spark discussion. Do you think earth-healing stones like serpentine could become more culturally valuable in 2026 than traditional gemstones such as diamonds? Share your thoughts, and consider posting this video in environmental, farming, or gemstone groups on Facebook or Reddit. Someone out there may discover that the stone they've overlooked for years is actually one of Earth's oldest healers. Number 6. Basalt, the forgotten lava stone that can restore the Earth's soil. The first time I knelt beside a basalt outcrop on the edge of an extinct volcano in northern Vietnam, the stone felt strangely familiar, dark, heavy, textured like cooled midnight. But when I cracked open a smaller piece, the scent of ancient fire seemed to escape from it, as if the volcano that birthed it was still breathing somewhere deep below. And if that image already stirs something in you during these opening seconds, feel free to leave a comment. It tells me you're still here with me, walking into the long story of how a humble volcanic stone may help heal the planet. Basalt is one of the most widespread rocks on Earth, found across Iceland, Hawaii, the Pacific Ring of Fire, East Africa, and ancient volcanic plains stretching through India. Where lava once roared across the land, basalt cooled into hard, black columns, silent monuments to geological violence. Archaeologists studying Neolithic farms discovered crushed basalt layers intentionally added to soil. These early agriculturalists didn't understand mineralogy, but they knew their crops grew faster, stronger, and greener when basalt dust mingled with the fields. Today, environmental scientists know why. Basalt slowly releases vital minerals, magnesium, potassium, calcium, and iron, back into the soil. More importantly, through a process called enhanced rock weathering, crushed basalt can react with atmospheric CO2, locking the carbon into stable compounds. In simpler terms, basalt can help pull CO2 out of the air while restoring soil fertility. Extraction of basalt is far gentler than many mining operations. Because basalt forms enormous surface flows, it is often quarried from exposed rock rather than deep underground. This reduces habitat destruction, water contamination, and energy use. And once crushed, basalt can be redistributed into fields or used to rehabilitate damaged ecosystems. Visually, basalt has a raw beauty: charcoal black surfaces, dark gray columns, porous textures dotted with tiny mineral crystals. It forms in shapes ranging from smooth, river-rounded stones to dramatic hexagonal pillars like those seen at the Giant's Causeway. Though rarely used as a gemstone, its strength and symbolism made it a foundation stone in ancient temples and agricultural rituals. Ancient communities across Asia and Africa believed basalt carried the memory of fire, a stone that survived destruction and therefore could support life. Some archaeological sites reveal basalt altars and pestles, polished smooth by centuries of use. The stone wasn't worn for beauty, it was used for survival. If the idea that this dark volcanic stone, born violently, silent for millennia, can rejuvenate soil and capture carbon surprised you, feel free to share your first impressions in the comments. I'd love to know what part of this story caught your attention. And before we continue, here's a question for you. Do you think stones that actively fight climate change, like basalt, could become more culturally important in 2026 than traditional luxury gemstones like diamonds? Share your thoughts, and consider posting this video in environmental, geology, or farming groups on Facebook or Reddit. You never know who may find new hope in a stone shaped from ancient fire. Number 5. Calcite, the white stone that neutralizes the Earth's wounds. The first time I encountered calcite deep inside a collapsed mining tunnel in Romania, it was glowing faintly under the beam of my lantern, almost like a frozen candle flame trapped in stone. Its soft white crystals formed delicate layers along the cavern walls, reflecting light in a calm, almost soothing way. And if that quiet glow already captured your attention in these opening seconds, feel free to leave a comment. It tells me you're still here, following this path into one of Earth's most surprising protectors. Calcite, despite its gentle appearance, is formed in some of the most dramatic environments on the planet. You'll find it in limestone caves of Vietnam, the chalk cliffs of France, the ancient reefs of Mexico, and the karst mountains of China. In many of these places, archaeologists discovered calcite carvings near ancient waterways, small figurines, ritual bowls, even early water filters made from porous calcite blocks. Early civilizations didn't know the chemistry, but they knew calcite changed the taste and clarity of water. Modern science explains what they sensed intuitively. Calcite is a natural acid neutralizer. When acidic water, like runoff from mines or polluted rivers, passes over calcite, the stone slowly dissolves, raising the pH and restoring balance. This simple reaction has saved countless waterways from the destructive effects of acid mine drainage. In fact, many modern environmental restoration systems place calcite barriers in streams to heal water as it flows. Extraction of calcite is surprisingly gentle compared to other industrial stones. Many deposits are gathered from surface quarries, natural cave formations, or shallow limestone layers. And because calcite is abundant and forms in renewable geological cycles, mining pressure is low, allowing landscapes to recover quickly. Its appearance is one of Earth's softest signatures. Milky white crystals, transparent rhombohedral shapes that catch light like broken ice. Ancient artisans carved calcite into masks, idols, and ceremonial vessels. In Egypt, sheets of orange calcite were used as windows in temples, letting sunlight filter through like sacred fire. In Mesoamerican cultures, calcite was ground into powder for purification rituals, symbolizing clarity and renewal. Its environmental power lies in something subtle. Calcite doesn't attack pollution, it neutralizes it. It doesn't fight violently, it restores gently, making it one of Earth's most peaceful protectors. If the idea that a soft white stone could heal rivers, balance ecosystems, and even shape ancient purification rituals surprised you, feel free to share your reaction in the comments. I'd love to know what part of its story spoke to you most. And before we move forward, here's a question to spark discussion. Do you think earth-healing stones like calcite could gain cultural value in 2026, perhaps even more than traditional luxury stones like diamonds? Share your thoughts, and consider posting this video in geology, environmental, or archaeological groups on Facebook or Reddit. You never know who might discover that the stone they overlooked is the one healing the water they drink. Number 4. Bentonite clay, the soft earth stone that absorbs the world's toxic secrets. The first time I saw bentonite clay being unearthed was in a quiet valley in Wyoming. A mining engineer had sliced a narrow trench through the hillside, revealing layers of pale gray clay packed like pages of an ancient book. When I picked up a small handful, I was shocked. It felt cool, velvety, and alive. And as it dried in my palm, it tightened, pulling at my skin as if it were absorbing everything it touched. And if that subtle, almost living reaction already caught your attention in these opening seconds, feel free to leave a comment. It helps me know you're still journeying deeper with me into this chapter of environmental archaeology. To understand why bentonite appears as stone number 4, we must travel across landscapes shaped by ancient volcanoes. You'll find it in Wyoming, where one of the world's largest deposits lies hidden beneath rolling plains. Across Turkey, where prehistoric lakes trapped a volcanic ash and transformed it over millions of years. And throughout Japan, where mineral-rich clays were used in early purification rituals long before the material's unique properties were understood. Bentonite forms from the weathering of volcanic ash. Ash that once erupted violently into the sky, settled into ancient lakes or seabeds, and slowly transformed into a clay capable of absorbing toxins at an astonishing scale. Archaeologists studying early settlements in Anatolia found bentonite-lined pits that filtered oil and impurities from food storage, a primitive yet effective environmental technology. Today, bentonite clay is one of the world's most important environmental protectors. It acts like a sponge for pollution, absorbing heavy metals, binding organic toxins, capturing oil from chemical spills, and sealing contaminated landfills to prevent leakage. Its ability to expand up to 15 times its volume when wet makes it ideal for creating protective barriers underground, blocking pollutants from reaching groundwater. No gemstone, even the rarest, has contributed to environmental safety on this scale. Extraction of bentonite is generally gentle. Because it forms in soft, shallow layers, miners use low-impact strip mining, removing only thin sections at a time. The land can often be restored quickly, and vegetation returns fast once the clay is removed. Compared to deep mineral extraction or chemical refining, bentonite mining leaves a lighter footprint. Its appearance is humble but beautiful in its own way. Soft gray, off-white, pale green, sometimes hinting at blue or cream, depending on its mineral content. When processed, it becomes a fine powder that swells and locks tightly onto pollutants, forming a natural seal. Ancient civilizations used bentonite for healing rituals, purification ceremonies, and even early water filtration. They didn't know the chemistry, but they understood the symbolism, a stone that absorbs impurities, both physical and spiritual. If the idea that a simple clay born from the ashes of extinct volcanoes could protect entire ecosystems surprised you, feel free to leave a comment. I'd love to know what part of its story struck you the most. And before we move forward, here's a question for you. Do you think pollution-absorbing stones like bentonite clay could gain more cultural value in 2026 than traditional gemstones, such as diamonds? Share your thoughts, and consider posting this video in environmental, geology, or sustainability groups on Facebook or Reddit. You never know who might discover that the world's softest stone is also one of its strongest protectors. Number 3, Peridotite, the underground giant that drinks carbon faster than a forest. Voiceover, 500 words. Archaeological reporter tone. The first time I traced my fingers across a wall of peridotite deep inside the Ophiolite Mountains of Oman, I felt something I rarely experience in field archaeology. Urgency. The rock was warm, dense, and etched with pale veins that looked like lightning frozen in stone. And when a scientist beside me whispered, "This is the fastest CO2-eating rock on Earth," the cavern suddenly felt less like a geological formation and more like a warning, or a solution waiting to be awakened. And if that realization already sparked your curiosity in these first seconds, feel free to leave a comment. Just one line to let me know you're still walking with me through this startling discovery. Peridotite is not an ordinary rock. It comes from the Earth's upper mantle, pushed to the surface through tectonic uplift and ancient oceanic collisions. You'll find it in Oman, the Papua New Guinea highlands, the Marianas, Albania, and even along the California coastal ranges. Wherever peridotite reaches daylight, it carries with it a geological power unmatched by any other stone. Archaeologists studying Bronze Age settlements near Oman's mantle exposures discovered peridotite fragments intentionally placed near early water basins and agricultural pits. The people living there didn't know the chemistry, but they sensed the land was unusually fertile and the water unusually clear. Modern scientists now understand why. Peridotite naturally reacts with carbon dioxide, locking it away inside stable carbonate minerals. Not over centuries, but in months. In some lab simulations, powdered peridotite captured CO2 up to 1 million times faster than natural weathering. This ability has sparked global climate discussions. Could peridotite be the mineral that helps reverse carbon emissions? Extraction is surprisingly low impact. Because peridotite forms in large exposed masses, collecting it often requires only surface scraping or shallow coring. The stone is abundant, accessible, and doesn't demand energy-heavy chemical processing. When used in carbon sequestration projects, peridotite is spread across coastal zones or mixed with seawater, where it rapidly binds CO2 into solid minerals, removing carbon from the atmosphere permanently. Visually, peridotite is rugged and unmistakable, dark green to olive black, streaked with creamy veins of serpentine and carbonate, heavy, iron-rich, and textured like ancient armor. It's not a gemstone meant for jewelry. It's a geological workhorse, built for endurance, transformation, and deep earth alchemy. Ancient cultures treated peridotite as a stone of strength, using it in foundational structures and ritual offerings. Today, scientists view it as Earth's natural carbon filter, a mineral born in fire that cools the climate it helped shape. If the idea that a mantle-born rock could help heal the atmosphere shocked you, feel free to share your thoughts in the comments. I'd love to know which part of its story surprised you the most. And before we move onward, here's a question to stir deeper discussion. Do you think climate-healing stones like peridotite could become more culturally valued in 2026 than traditional gemstones like diamonds? Share your perspective and consider posting this video in environmental or geology groups on Facebook or Reddit. You never know who might be inspired by a stone forged in Earth's depths to protect Earth's future. Number 2. Zeolite, the crystal sponge that purifies water, air, and even the Earth itself. The first time I watched zeolite being extracted from a quarry in northern Turkey, the scene felt almost deceptive. Workers carved into what seemed like ordinary pale rock, but when the stone fractured, the interior revealed a delicate lattice, tiny pores and channels forming geometric perfection. It looked like architecture made by time itself. And if that hidden complexity already captures your attention in these first seconds, feel free to leave a comment. It tells me you're still walking with me into this extraordinary story. Zeolite forms in places where fire meets water. You'll find it across the volcanic plains of Turkey, the ancient lava beds of Japan, the Himalayan foothills, and the western deserts of the United States. It begins as volcanic ash settling into alkaline lakes, slowly crystallizing into a mineral with a structure unlike anything else in nature. A honeycomb of microscopic tunnels capable of trapping toxins, pathogens, and chemical pollutants. Archaeologists studying prehistoric settlements in central Anatolia discovered vessels coated with zeolite used to keep water fresh during long, dry months. The people didn't understand molecular filtration, but they understood something was happening, something that protected them. Zeolite became part of early purification rituals, water storage practices, and even burial rites. Today, modern science confirms what ancient communities sensed intuitively. Zeolite is one of Earth's most powerful natural filters. It can remove heavy metals from contaminated water, trap ammonia and nitrates in agricultural runoff, purify air in industrial zones, stabilize soil polluted by chemical spills, and even neutralize radioactive elements in specific forms. Its ability to exchange ions gives it the unique power to absorb toxins and release harmless minerals in return, a balancing act no other natural stone performs so efficiently. Extraction of zeolite is remarkably low impact. Because it forms in shallow, widespread layers, miners use open-pit methods that remove only thin upper deposits. Once the stone is collected, quarries can be restored quickly with vegetation and soil. Compared to metals or rare gemstones, zeolite mining is light-footed, returning land to nature faster and more completely. Visually, zeolite is understated but mesmerizing. White, cream, or pale green crystals, sometimes forming soft cloud-like masses, other times sharp geometric cages sparkling under sunlight. Though rarely used in jewelry, its structure is what makes it invaluable. A crystal sponge built not for beauty, but for healing the environment. Ancient cultures believed zeolite absorbed not only impurities, but negative energy. Modern environmental science now verifies at least half of that belief, the physical part. In polluted rivers, damaged farmland, or toxic industrial sites, zeolite quietly goes to work, absorbing what the world doesn't want to face. If the idea that a soft-looking mineral could trap poisons and cleanse entire ecosystems surprised you, feel free to share your reaction in the comments. I'd love to know what part of zeolite's story struck you the most. And before we move to the final stone, here's a question to spark discussion. Do you think purification stones like zeolite could one day become more valuable in meaning than diamonds? Share your thoughts. And consider posting this video in environmental or geology groups on Facebook or Reddit. Someone out there may discover that the most important crystal in their life isn't the one that shines, it's the one that cleans. Number 1. Activated charcoal, the black stone that can clean an entire world. The first time I discovered ancient traces of activated charcoal buried beneath a collapsed fire pit in northern Laos, I didn't recognize its importance. It looked like nothing, just a dull black fragment, so light I almost mistook it for burnt wood. But when I brushed away the surrounding soil, something remarkable happened. The fragment didn't crumble. It didn't decay. Instead, its surface revealed thousands of microscopic pores, tiny openings carved not by nature alone, but by fire, water, and time. And if that unexpected revelation already captures your attention in these first seconds, feel free to leave a comment. It tells me you're still here, stepping into the story of the stone that purifies civilizations. Activated charcoal, often considered too humble for gemstone conversations, may be the most effective environmental protector humanity has ever discovered. It forms wherever organic material, wood, bamboo, coconut shell, encounters fire under oxygen-restricted conditions. This carbonized material, once cooled, develops a porous structure capable of absorbing toxins at a scale unmatched by most natural minerals. Archaeologists have found traces of charcoal filtration systems in ancient Egyptian wells, Roman water channels, and even early Mayan purification pits. Without modern chemistry, early civilizations understood one truth. Black stone makes water safe, and safe water meant survival. Today, activated charcoal is used to purify environments on every continent. Its abilities are staggering. It absorbs chemical pollutants from industrial water, traps pesticides in agricultural runoff, removes toxins and heavy metals from contaminated land, filters air pollutants, including volatile organic compounds, even reduces odors and chemical gases in packed urban environments. No other environmental material on this list has as many applications across land, water, and air. Extraction, or rather production, of activated charcoal is one of the most environmentally balanced processes known. Unlike destructive mining of rare minerals, activated charcoal is produced from renewable biomass, bamboo forests, coconut farms, or agricultural waste, and because the carbon is locked into a stable form rather than released as CO2, the process can even support carbon sequestration efforts. Visually, activated charcoal is deceptively simple. Deep matte black, feather-light, porous like volcanic stone, breaking apart cleanly under pressure. And yet, when examined under a microscope, its surface resembles a labyrinth. Millions of tunnels and pockets waiting to trap impurities. This internal universe of pores gives the stone its purifying power. Ancient cultures believed charcoal absorbed not only physical impurities, but spiritual ones. Priests burned it in temples, travelers carried it in pouches, healers used it in ritual cleansing. They didn't know the chemistry, but they knew the effect. If the idea that the most powerful environmental stone in the world is neither rare nor beautiful surprised you, feel free to share your reaction in the comments. I'd love to know what part of its story left the biggest impression on you. And as we close this environmental journey, here's a final question to spark discussion. Do you think a humble stone that cleans the air and water, like activated charcoal, could ever be valued more than diamonds in 2026? Share your thoughts and consider posting this video in environmental, sustainability, or archaeology groups on Facebook or Reddit. You never know who might be inspired by a black stone that quietly keeps the world alive. And that brings us to the end of today's journey. If you're still here, listening to these final moments, thank you. It means more than you think. Every video in this series takes days of research, cross-checking archaeological sources, and reconstructing stories buried beneath time. Your presence, your comments, your likes, they are the reason this journey continues. If today's exploration opened your eyes to a new side of stones and the hidden forces that protect our planet, consider leaving a like or subscribing to the channel. Just a small gesture, but it gives me the energy to keep digging deeper, to keep bringing you the stories the world has forgotten. And if you thought the stones in this episode were surprising, wait until the next chapter. In the upcoming video, we'll step into a darker corridor of geological history, stones whispered about in ancient texts, minerals believed to hold energies that early civilizations feared and respected, and a few specimens so rare that they almost never see the light of day. A new journey begins soon, one that will take us from volcanic tombs to forgotten riverbeds, from ancient burial sites to caves sealed for centuries. So stay curious, stay safe, and stay with me. Thank you for watching, and I'll see you in the next chapter of this never-ending quest for the world's most mysterious stones.